I'm going to go through the rainwater collection exercise. You can follow along and fill it out as we go here. So what we have here is a store, and we want to collect the water off the roof and use it for irrigation. We're given the area of the roof and then the efficiency of our collection, 82.2%, and that's pretty normal. And then we have the information here, the data for per 2-month period, just to make it convenient here. And we have the irrigation needs in thousands of gallons. And we're going to do this two ways. One, we're going to just figure out the tank volume we need if we want to store and use all the rainwater. That's typically what you'll find if you look up instructions in a rainwater collection manual. And then we're going to say, rather than coming up with the volume needed, say we have a 100,000 gallon tank, and then we'll walk through the time steps and we'll say, for this time step, do we spill any water? Do we need to purchase water to meet our irrigation needs if we run out of water in our tank? And we'll walk through that. I'm going to do this in a spreadsheet. I've copied the information here. Typically for in-person class, we use paper for this. You can do it either way you want. So I have here the data on the rain, so I need to figure out how much rain volume we're getting. So I have that equals 9 inches of rain. I probably want this in feet, so I'm going to divide by 12 to get feet of rain times the area, and I'm going to hit F4 to fix that, and times the efficiency. Hit F4 again to fix that. That's the rain volume for each time period in cubic feet. And then I'm going to operate in gallons here because I have the irrigation in gallons. So I'm going to take that number, feet squared, times the unit conversion of 7.48 gallons per cubic foot. I can just type 7.48, but I'll go ahead and put that formula in there. And then divided by 1,000 because I'm doing in thousands of gallons. So you can see a real nice convenient number there. So that's why those numbers were chosen. So now I have the rain volume coming in, and then I have the rain volume going out of my tank that I haven't built yet. So I want to know the difference between that, in minus out. And so it's that minus that. So the first time period, I'm getting 150,000 gallons in. I'm not using any of that, so I have 150,000 to fill up my tank. And I walk through the time periods like that. And oops, I forgot to put this in 1,000 gallons. 200, 400, 400, 200. I'll have that in the handout like that with the 200, 400, like that. And then, so that's the difference. And then I want to do the accumulation. So if I start with the tank at 0, then the first month, I'll go ahead and label this accumulation. The first month, I have 150 more coming in, 150 more coming in than going out. So I've added that to my tank. So I have time step before we were at 0, plus this time step, I'm adding 150. So I do that again, copy this down, or that just says that we have the equals the time step before plus 50 extra coming in, 250 minus 200. And then, so we're up at 250, and then the next time step, we're have 50 out, more out than coming in. Next step, we have 300 more out than coming in, and we go like that. So that's the accumulation. That's the level in the tank. Well, was that the level? We can't have 150 level in the tank. Well, here, I'll show you something here in a second. So we have the maximum of this is 200. And the minimum is minus 150. I can look at it, or I could put formula, minimum, maximum formula in Excel. So the max minus the minimum is max minus the minimum. So it's minus a negative 150, 350. So there's 350 difference between the lowest point and the highest point. So that's the size of tank I need. And if that negative bothers you, just think of it, if I have 100 minus 150 is the minimum. If I started with 150 in the tank, then we build up to 350, so that's the size of the tank, and then we go down to 0. And actually, you want to build a little capacity in that, so you probably want a bigger tank than that, but this is a very simplified thing. So that's the size of the tank we need if we want to use it all. But what if we have a 100,000 gallon tank? What happens then? So I'm just going to talk through this instead of using a lot of calculations. So I'm going to have the right here tank level, overflow, and purchase. So if we start out 0 in our tank, in our 100,000 gallon tank, here we start at 0, we didn't know the size of the tank yet. And again, if we started at 150, we're not going to go negative on it. So the first time step, there's 150 more coming in than going out. We can only go up to 100. So we have 100, our tank is full, and maybe I'll call this spill instead of overflow. So then we have to spill out 50. Next time step, we're at 100. We get 50 more in that goes out. So it stays full. And again, we're spilling 50, spilling all that 50. Now, next time step, we're starting out at 100, not 150, because the maximum is 100. We're using 50 more than what comes in. So our tank level goes from 100 down to 50. We lose 50. So I can make the formula of 100 minus 50. And everything's okay. We didn't spill any. We didn't purchase any. We're fine there. Now, the next month is in the summer, not a lot of rain and a lot of water usage. So we need 300 more than what came in. We need 400, only 100 came in, so we need 300 more than came in. So our tank goes down to 0, and we use 50, and we need 300, so we're going to have to purchase 250. And then this one, where our tank's empty, but we're using the same amount that comes in. So we just use it as it comes in. So our tank is still 0. And we're just, okay. So it's all good. And then finally, the last time period, November, December, we're not using any. And we have 150 come in, and none go out. So our excess is 150, or our in minus out is 150. So our tank is up to 100 now. And then we again spill 50. Let me go back to the assignment. And I'm going to change this word to spill instead of overflow. All right, so did you use YAS or YIBIS? Yield after spillage, yes, would be we get the water into the tank, and then if our tank's full and we get more water in, that has to be spilled out, and then we take our water out. Yield before spillage, we get the water into the tank. If our tank is 100,000, we get 50,000 in. We're at 150,000, which actually more than the tank has. Then we can use that 50,000. And then after we're done, we overflow. So let's look at what we did. Let's look at this time step here. So it was full. We had 50 more in than came out. So we said we spilled 50. Well, we got 250 in and we used 200. If it's full and we get 250 in when it's already full, we have to spill all of that 250. And then we have to use 200 and we only have 100. So we'd have to buy 100. So that's not what we did. So apparently we use the yield before spillage. So we said we had 100,000. We got that 250 in. We're up to 350. We used 200. That takes us down to 150. So we spill out 50. So what we did, we really did the yield before spillage algorithm. And that's the one that probably makes the most sense. Again, like I said in the other presentation, if you do it day to day, it doesn't make that much difference. And also in the assumption we made in our first one we did here, we also use what are we saying we do? The yield before spillage algorithm. So that's a little exercise on the rainwater collection. Let me know if you have any questions.